Welcome. I'm going to go over horizontal projectiles 2 step by step so you can take a look at it. Okay. All right. So Joe shoots an egg horizontally out of a second story window. So I'm going to start with a little sketch. All right. And so the egg is going to follow a parabolic trajectory. It lands 7 meters from the edge of the building. And the window is 4 meters from the ground. Okay, and we want to know how long is the egg in the air. That's our unknown. Okay, so what do we know? Let's see. For all horizontal projectile problems, the VIY is 0 at the top. Actually, this is going to be true for all projectile problems unless things are literally shot down or shot up, which is beyond the scope of this course because you need a quadratic to solve it. All right. Okay, so what else do we know? Well, let's see. Let's start with our given information. So the range is going to be 7 meters, all right? And the distance it falls is going to be 4. And since I'm going to make down the negative direction, then I'm going to make this negative, okay? All right, and that's meters. Good. So if you forget to put that negative in and you make down your negative direction, you might find yourself trying to take the square root of a negative number. That's your hint to go back and find where the negative is. All right, so what else do we know? So remember, the way these problems go is usually find time on one side and use that to find the unknown on the other side, right? And in this problem, we've broken it down and reminded you to find time first. In order to use accelerated motion, what you need is 4 variables, including the unknown, and we have 1, 2, 3, which means we need one more. Since we're on the Earth, the acceleration due to gravity is negative 9.81, and again, since down is our negative direction, we're there. Now we have our 1, 2, 3, 4 things, and we can pick our formula. Give me a second while I get that. Okay, so we're going to pick from one of these formulas for accelerated motion. All right, and we want something that has all of these variables and nothing we don't know, right? Like, they didn't ask about final velocity. We don't care about it. All right, so the formula I'm going to pick that has VI, D, A, and T is this guy right here. Okay, so the formula is D equals VIT plus 1/2 AT squared. Now, you need either to be really careful about keeping your X and Y separate, or you need to put in subscripts, which I'm going to do. I don't usually do it on the A since there's only an acceleration in the Y direction. There is no acceleration in the X direction. All right, so now I can plug in. So since the VIY is 0, this whole term drops out, and I can then plug and chug. So I've got negative 4 meters equals 1/2 times negative 9.81 times T squared. Okay. And now we're going to do some algebra. All right, so I'm going to drop units. So negative 4 equals negative 4.905 T squared. Divide both sides by that. And we get that T squared equals 0.81. And then I gotta take the square root of both sides, and I get that the time in the air is 0.9 seconds. So that's our first answer. Now it says, what's the initial velocity of the egg? That's in the X direction, so what we're looking for here is this, Vx average. The formula we're going to use for that it's the same formula we're always going to use for horizontal motion. How did I already lose my stupid reference tables? Hold on. Here they are. All right, so the formula we're always going to use for horizontal motion is V equals D over T. Remember, this is dangerous to use for accelerated motion. It can be done. People usually goof it up. Okay, so the formula I'm going to use is V equals D over T. And again, you either need to be really careful about keeping X and Y separate or use subscripts. So I'm going to put in subscripts. All right, so now we can plug and chug. So that equals the dx, which is 7 meters, times the time that we figured out, which is 0.9 seconds. And we get that Vx equals Right, I found an error somewhere, so I'm going to check this. I found my error. I forgot this slash here. Alright, so if I do actually 7 and divide that point by 0.9, I get the correct answer, which is that Vx equals 7.7 meters per second. Boom. Alright, next question. Alright, just here. Okay. Let's see. Okay, so a car drives off of the cliff and lands. So again, I'm going to start with a picture. So we have a horizontal velocity. It goes there. All right, the cliff is 90 meters high. And we want to, and it lands 50 meters from the base. That's its range. And we want to know the velocity. Now, let's start with what we know. Again, I'm going to make down the negative direction. Let's see. The dx is 50 meters. And the distance that the car is going to fall is 90 meters. And since it's falling, I'm going to put that in negative, because down is our negative direction. All right. Now, seems like we don't have nearly enough, but that's because there's so much hidden information. We're on the Earth, so the acceleration due to gravity is negative 9.81 meters per second squared. All right, and again, because down's our negative direction, I'm going to make that negative. And then the other hidden piece of information that's true for all horizontal problems is that VIY is 0 at the top. That's actually true for all projectile problems, as long as you're not actively shooting something down or up at an angle. All right, so now, when in doubt, find time first, because that's the one thing that's true for both sides. So we don't have enough information right away to find the unknown, so we're going to go right at here and use this side to find time. Okay, so let's see. Once again, we're going to use this formula. All right, spoiler alert, this gets used a lot in projectiles. VIT plus 1/2 AT squared. And again, be really careful about keeping your x and y separate, or use subscripts. All right, so let's, again, VIY is 0, so this drops out, so we can now plug and chug. So negative 90 meters equals 1/2 times negative 9.81 times t squared. All right, and then again, I'm going to do algebra here and solve this. Give me a minute. Okay, so I did all my algebra, and I came up with that the time was 4.28 seconds. That's a long time to regret your decision to drive off the cliff. All right, now the next step, sorry I'm running out of room here, is so now that I know the time is 4.28 seconds, now I have enough information to find dx. And again, for horizontal motion, we're always going to use this guy. All right, so sorry that we're going to get so cluttered here, but here we go. All right, so Vx equals dx over t. So Vx equals 50 meters all over 4.28 seconds. And I get that the Vx equals 7.7 meters per second. Okay, great. All right, and then finally, the last question here. Move down a little bit. Okay, so again, we have a little t-ball here, and we're going to hit it horizontally. The Vx is 25 meters per second. And the ball, it's going to go like this, right? So it's 1 meter from the ground, which means it's going to fall 1 meter. And again, I'm going to do negative, down as the negative direction. All right. Like our hidden information or other problems, the VIY is 0 at the top. True for almost all projectile problems. Another hidden information is, since we're near the Earth, 9.81 meters per second squared. All right. So we're going to use the x side to find time. Okay. And, yeah, same formula. So D equals VIT plus 1/2 AT squared. And again, be careful about keeping x and y separate. And VIY is 0, so let's plug and chug. Negative 1 meter equals 1/2 times negative 9.81 meters per second squared times t squared. When you do the algebra here, you're going to get that t equals 0.45 seconds. All right. Now, what is its range? The dx. Again, we're going to use good old Vx equals dx over t. I'm going to rearrange that and get that dx equals vxt. So let's see, Vx is 25 meters per second. Time is 0.45 seconds. So the range is 11.3 meters. And we're done.